When solving a system of equations by substitution, we're going to take advantage of the fact that in both of the equations, the x's have the same value and the y's have the same value. So if we can set the x equal to a value or an expression, and we can set the y equal to a value or expression, we can substitute that value into the other equation. And here's how it works. In our first example, we're going to have y is equal to 6x minus 11 and negative 2x minus 3y is equal to negative 7. We already have y set equal to something. Since this y and this y are the same thing, that means this y is also equal to 6x minus 11. So we're going to take advantage of that fact and substitute that entire expression down into the y for our second equation. So that will look like this. We'll have negative 2x minus 3 times all of the stuff that's equal to y, 6x minus 11, and that is equal to negative 7. We just took this entire second equation here, substituted what y is equal to down in here. Now, we only have one variable that we're working with, so we can solve this out like a regular linear equation. Distributing our negative 3, we have negative 2x minus 18x plus 33 is equal to negative 7. Combining like terms, negative 20x plus 33 is equal to negative 7. Then subtracting 33 from both sides, negative 20x is equal to negative 40. Dividing both sides by negative 20, x is equal to 2. Now that we know what x is equal to, we need to plug that back into one of our equations. We're going to plug it back in here to this top one. Y is equal to 6 times 2 minus 11. This is 12 minus 11 is 1, so y must be equal to 1. Finally, don't forget we need to write our solution as an ordered pair, x comma y, so we're going to have 2, 1 as our final answer for this system of equations. In our second example, we have 2x minus 3y is equal to negative 1, and we have y is equal to x minus 1. Since we already have y equal to something, this is the perfect opportunity to use substitution. This y is the same thing as this y, so let's rewrite our first equation with the value that y is equal to substituted in, and now solve for x. 2x is equal to minus 3x plus 3, which is equal to, 2x minus 3x plus 3 is equal to negative 1. Combining like terms, negative x plus 3 is equal to negative 1. Subtract 3 from both sides. Negative x is equal to negative 4. So x is equal to a positive 4. We now will substitute this back into one of our equations. We'll use this one down here because it's simpler. Y is equal to 4 minus 1, which means y is equal to 3. Finally, make sure we write our answer as an ordered pair, 4, 3, and this is our final answer for this system of equations solved through substitution. For our third example, let's have negative 5x plus y is equal to negative 3, and 3x minus 8y is equal to 24. So what do we do here? We don't have a variable set equal to anything, so we're going to make a variable set equal to something by manipulating one of the equations. This top one's going to be the easiest one for us to do because we have y by itself with no coefficient. So we're going to turn this into y is equal to, subtracting negative 5x from both sides, 5x minus 3. Now that we have y set equal to something, we can substitute it into the other equation. y is equal to 5x minus 3 over here, so we're going to substitute that in right there. 3x minus 8 times 5x minus 3 is equal to 24. Next, we solve it like a linear equation. Distribute this negative 8, we have negative 40x, and this will be positive 24. 3x minus 40x, this is 24. Now we subtract 24 from both sides, combine like terms. Negative 37x is equal to 0, subtracting 24 from both sides. This means x is going to be equal to 0 when we divide both sides by 37. Now that we know x is equal to 0, we can substitute that back in. And let's substitute it back in up here. We could substitute it into this equation and this equation. Let's do this one because we already have y set equal to something. When we have 5 times 0 minus 3, this is now 0 minus 3, which is negative 3. So y is equal to negative 3. Finally, we write our solution in an ordered pair. And that is our final answer for this system of equations. X is equal to 0, y is equal to negative 3. Just like the last video, I want to address the two special situations that you can come across, where there are no solutions or infinite solutions. So let's take a look at 4x minus 14y is equal to 21, and 7y is equal to 2x plus 49. Alright, so how can we solve this with substitution? Well, one thing that we could do is we can divide everything in this equation by 7 and isolate this y. So that would look like this. Y is equal to 2/7 x plus 49 divided by 7 is 7. And then substitute this value into this y. So that would be 4x minus 14 times 2/7 x plus 7 is equal to 21. From here, we're going to solve it out like a linear equation, multiplying everything in here. Negative 14 times 2/7 would be negative 2 times 2 is 4, so negative 4. And then negative 14 times 7 is going to be 70 plus 28, 98. So negative 98. And from there, we have 21, 4x. Oh, this should be negative 4x. I forgot to include my variable. Now let's combine like terms. Negative 4x and 4x will be 0x's. So we have negative 98 is equal to 21, which is not true. It does not make sense. There is no value we can plug in for x. There's no value we can plug in for y that's gonna make negative 98 equal to 21. This is just a false statement. So for this particular set of equations, this system of equations, there is no solution. And that is our final answer. No solution for this set of equations. The other special case that you can come across instead of no solutions is you could have infinite solutions. And here's what that looks like with substitution. Y is equal to negative 3/4 x plus 9, and 6x plus 8y is equal to 72. We already have y isolated, so let's plug in this value down here for this y, since this y and this y are the same thing. We'll have 6x plus 8 times negative 3/4 x plus 9, that's our value for y up here, is equal to 72. Now we'll solve out for our variable x. 8 times negative 3/4 is negative 6x. And then 8 times 9 is 72. Drop this 6x down, combine like terms, 6x minus 6x is 0, plus 72 is 72. And we have not done anything to this side, so that stays the same. 72 is equal to 72. This is a true statement. There is nothing that we can plug in for y, there is nothing that we can plug in for x that will make this a false statement. So this has infinite solutions. Finite solutions. One quick way that you can see if something has infinite solutions is if these two equations can be made to be the exact same thing. Let me show you what that looks like. We're going to take this entire equation and multiply it by 4, so we get rid of this denominator. So we have 4y is equal to negative 3x plus 36. Then we're going to take this entire equation and divide it by 2, because 2 is a common factor that I can factor out of everything. So this is now 3x plus 4y is equal to 36. When we add 3x to both sides on our top equation, our 4y will stay the same. This 3x becomes positive, is equal to the 36 that's left over here. Since these two equations are the same thing, that means there's going to be infinite solutions. Whatever we plug into the top equation to make it work will also work for the bottom equation because it's the same thing. That is a way you can figure out if a system has infinite solutions, if the top equation and the bottom equation both are the same equations. That's all I've got for you today. If you found this content to be helpful, consider liking and subscribing, and if you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.